and this is my project, Rooty Tooty Point and Shooty. Goals. In concept, this was supposed to be a hand tracking point and shoot game in VR space. In execution, hand tracking in VR, no gaming implementation. So how does it work? As you can see here, I am controlling the balls with my hands. That is because the balls are in the 3D space while the fingerprints are still in the 2D space. And they have a different implementation, which I will talk about later. So what does and does not work? Hand tracking works. 2D hand tracking to 3D sphere movement translates on screens of some sizes. I'll get into that later, of course. 3D movement around the player, which exists to be shot at, but cannot be, can identify finger guns some of the time. And the VR space movement on the phone and computer. What does not work? It cannot shoot the ball. There's no collision physics. Hand tracking to sphere movement translates do not work on most screen sizes, just a couple. The accuracy of finger gun identification is very low, and the sphere tracking only works in a small box within the VR space. So basically, it cannot go outside of a certain realm which the player can move about. So let's review the code. So I used a lot of resources: glitch.com, A-Frame, Vue.js, Hands-Free.js, P5.js, which I'm not going to talk about, and ML5.js, which I'm also not going to talk about much because they are really just supporters. ML5.js really just is the machine learning aspect, and then Galaxy Kate A9, someone who I am currently working with and a professor here at Northwestern, and Free3D, which I'm also not going to talk about. That's just where I got my models. So glitch.com, that's just where this is hosted. It means that I can share it with basically anybody as long as they have the link. You can find it on there, and so it's a live source where you can just get everything in one place. No need for zip files, which is really awesome. But let's talk about Galaxy Kate A9 because there are definitely going to be some questions. So you'll start to notice that there are a couple things similar. That is because I used her code as a basis for mine, in that she already had machine learning. So basically, what she implemented was this training code. This code helped me be able to make these is a neural network trainer that just allowed me to train my hand movements. And so because my program does focus on hand tracking in VR, I can't really use this 2D space as much. So what I had to do was use both this and a second hand tracking movement that I created myself. So I calibrated the 2D hand tracking movement to the 3D movements on select screens. Basically what happened is because of the 2D space has a different grid system. So in 2D space, the y-axis, the x-y-axis 0, 0 is at the top left, while in VR space that is in the direct center. Also, y increases as it goes down in 2D space, while the opposite is true for VR space. So I had to create a couple equations to try to balance that out and make it possible for me to do hand tracking with the spheres and with this, so I could do the shooting, which the point of that was when I make a finger gun, I could shoot the spheres out and hit an object. So, what is A-Frame? A-Frame is just how I got this VR to work. As you can see here, I am controlling the ball with my hand still, but also moving around in VR. So this is what I was talking about when I said a small space. They can only move really within this box, and when they disappear, my hand is outside of that box. So I can move it from any distance. It'll still register my hand. But again, it can't move with me, which would be a huge problem for a VR game. So let me just show you the phone experience, because another great part of VR is this phone experience. Oh, there we go. So here's the phone experience, where you can see it doesn't do a great job of tracking hands. This is one of the examples of screens that it can't create the sphere on, but the fact that it still works is pretty great. So Hands-free is used by Kate specifically for the neural network training, and it's the reason that you're able to do finger movements with that is because it just makes it very easy, and so that's what it's trained on. It's trained with this because it's a lot simpler and it's a lot quicker to use. I of course had to do a separate one again for the spheres, which does build off some of the code from that. However, it also builds off a lot of different sources that I had to code myself because again, they do not translate well. So what's next? Given one more month, I could have done a lot more. So I spent most of the time trying to do the translation into 3D to 2D to 3D space because I was very invested in this. However, given that I mostly accomplished that task, really it would be trying to continue to get a correct equation that means that I could use it on really any screen, which would have been fantastic. Secondly, I did start to implement the ammo aspect of shooting. However, that also was not finished in time and worked so poorly I didn't film any of it because really it was sad to look at and you could barely see it. So given another month, I definitely could have implemented that. I'm not sure if I could have gotten the collision physics working perfectly, but I'm also positive I could have gotten some collision physics working. However, I was not able to do so, and because of that, I just was able to get the spheres working, which I'm still very proud of, as again, you weren't supposed to be able to do that because A-Frame is not built to handle 2D, and P5, which, if you remember before, P5JS, something I used, that is where the 2D space is. That does not translate well. It either all has to be 3D or it all has to be 2D, so the fact that I managed to do this is actually very impressive to me.